Thank y'all all for coming. Keep in mind, not only is this a real pleasure for myself to be able to speak in front of friends, family, members of my community, and also my mother and my father for the first time. And so this is pretty special, and my wife and my children. It's my mother's birthday. Happy birthday! And now the attention to your mom. The first thing I have up on here, if anybody knows me, they know I really kind of shy away from accolades, accomplishments. I really don't. It's not a reason why I do things. I think that we should all do things for people. We should all serve people. But I have a few of the things up here from me. I'm the coordinator of the exercise science program here at the University of Louisiana-Lafayette. This is my alma mater. I'm also the I have the Red Laurel Distinguished Professorship in Kinesiology. Yay! And then I'm the 2013 Leukemia and Lymphoma Society Man of the Year. Now, all of that said, what I find is absolutely fascinating is when I go back home, when I go back to Delta, Louisiana, and my class knows I'm from Delta, probably within the first 5 seconds of when I started the class, I mention it, so I'm very proud of my hometown. But one day I went to, they asked me to go help with some pictures, some Little League pictures. Brian, can you come work? Yeah, absolutely. And so the coach is Mr. Hewitt. He's introducing me to the kids. And he says, do you know who this man is? To the kids, right? They're children. So in the back of my head, I'm like, is he going to play his father was the principal for many years? That's how I've been known a lot. He teaches at UL, teaches at university. He says, do you know who this guy is? This is the public address announcer at the football game. So in reality, this on my business card it says public address announcer, Delta football, and that gets me places.
And why are you the public address announcer?
What's that?
Why are you the public address announcer?
Because they asked me.
Yeah,
yeah, well, when I'm, it's cliche. You ask someone all the time, hey, if you need anything, let me know. And maybe 99 times out of 100, yeah, I'll let you know. Well, I asked that to Coach Darcy. When I came back home, our head football coach, I'm back in town, got a job here. If you need anything, let me know. And then he threw out with, well, we need a public address announcer. I was not expecting you guys. So my educational background, and this is where one of the things that I really hold dear is trying to help students find their way. And when I say find their way, it's not necessarily exactly find their way, but to open up doors for options, which open up doors for new options, which open up doors for new options. It was something that I never really had when I was in school, and it's something that kind of, just when you really get into a cause, it's usually because of either something that happened with you or close to you. And that's how I always kind of felt. I felt that I lucked myself into success. I was literally just stumbled into a door that happened to be the right door for what I wanted to do. And so, 99 times out of 100, that wouldn't have happened. I just really got lucky, blessed, however you want to look at it. But I feel that students at least should know options. So I graduated Belton High School in 1995. I was never one to be overconfident in my abilities. I'm serious. Miss Armentor, the guidance counselor in Belton, Miss Joanne Armentor, she passed away from cancer. And I was in 8th grade, and she stopped me in the hall and said, Brian, I noticed that you didn't sign up for college preparatory classes. I said, yes, ma'am, I did. She said, well, don't you make honor roll? I said, yes, ma'am. She said, you need to take honor roll. So I wasn't even going to do that because I didn't have self-confidence in my ability to say, no, that's for smart people. And what I've learned, I'm going to talk about is that is irrelevant. So I went to, I forgot to swap it. Sorry, guys. I did my undergraduate at UL-Lafayette, and I needed a major, right? So I was like, well, my mom's a teacher, my dad's a teacher, my sister's a teacher, I'm going to be a teacher. Seems logical, right? I know what they do. It's not easy, but I know what they do. And so I substituted for my dad a couple times, and I was like, yeah, I might want to find no Moss. Don't call me. That's a special job. You know, in fact, when I meet someone and, well, what do you do? Well, I'm a teacher. Really, what grades? Well, I teach at the university. What do you do? I'm a teacher. Really, what grades? 5th grade. I hug them. You know, I hug teachers. I mean, especially at high school, junior high, that's real work. What I do is nothing compared to the work I do. So I needed a major. And I'm looking through the catalog, and you know, at the time, Bill Sachs, you know, wanted me to go play something, and my dad said, Shaq, you go to a school like that, if you want to be a doctor or you want to be a lawyer, but if you want to be a teacher or something like that, then you can just go to UL, right? that's exactly what he said. And so, and I remember, there's a few things I really remember from my dad. I mean, dad offers you a lot of lessons, and there's a lot of things that I recall, but 2 of the most important things I recall: vote, and always bring your wallet wherever you go. But I remember those things. And so when I needed a major, you know, I'm flipping through, I can't decide, probably like those high school kids, man, what do I really want to do? It's so rare that you really know what you want to do. And one of the reasons you may not know what you really want to do is because, you're welcome.
Sorry.
One of the reasons you may not know what to do is because you haven't been exposed to all of these options. You haven't entered the room that has more doors and then entered that door that. So of course, odds are you don't know what you want to do because you've only sampled a small fraction. But you know what I thought growing up your options were? Policeman, fireman, teacher, doctor. I mean, like 5 options. But there's 5,000 options out there. Right? So that was really important to me. And so I majored in sports medicine. I didn't even realize what it was. We didn't have athletic trainers in high school. When, in fact, for the public address announcement, ladies and gentlemen, Delton High School would like to thank Louisiana Athletic Care for their partnership in athletic training. We didn't have athletic trainers. We had a coach that, you know, coach, my hand. Man, it hurt when I do that. You know, and it's not their fault. I mean, they weren't trained in that. You know, we had an injury coach. I remember Barry Scott, one of a graduated high school with me, broke his forearm. And literally went to coach and said, Coach, I think I broke my forearm. And he looked at it and says, I'm going to take your word for it. Because, I mean, but now they have athletic training. So I saw in the catalog sports medicine. And I was like, wow, I don't know what the medicine part is, but I like sports. So I majored in that. And I want to say it was my junior year. I took a class and I sat right there. And all my friends, it was anatomical kinesiology, and all my friends were struggling. I mean, struggling, Dr. Joel. Struggling. And I'm like, how are y'all struggling? This is like the easiest class I've ever had in my life. What? How do you understand this, that, and other? And that's what my wheelhouse was. That's what I got. You know, there's so many things that I don't understand. There's so many things I don't get, but I finally found the one thing I got. I took a note, just listen, it just made sense. And what it amounted to was all those years, I'm going to talk about a little bit, just playing sports and doing things, it just helped to kind of make it fit. So I told myself, while I sat there, I said, that's what I want to do for a living. I want to do that. I want to get up there and teach the class with the enthusiasm that I understood. And so when I finished here, and again, for especially our young ladies and gentlemen in high school, you know, it's about opening doors, it's about meeting people, and it's about taking advantage of those opportunities, even when you don't even realize they're there. They are there. Southern Mississippi happened because of someone I knew. Now I'm taking a gamble on a plane, flying to a conference, and I'm sitting next to a gentleman who has a Southern Miss shirt on. And he says, what are you going to the conference for, son? I said, well, I'm trying to find a graduate assistantship that I hear they have where you can work as an athletic trainer and they pay for your time. And I said, what are you going to the conference for? He said, we're going to look for graduate assistants. Yes. Free interview, right? And I mean, after about an hour and 15-minute flight, he's like, well, this guy doesn't seem like he's going to kill anybody. Let's bring him on. And so I got my master's degree paid for, and that was in exercise science, and it was physiology stuff. And my favorite story was how I ended up here. You know, how does a guy from Delcom end up at Auburn? And it's you know, throwing a dart at the dartboard, and I'm going to the middle of Alabama. who you know, making connections. My head athletic trainer, Matt Smith from Southern Mississippi, talked like he was from Mississippi, good old Mississippi boy. And I talked like I was from South Louisiana at the time. So, and that was when the water boy came out, so you know, I was like, I was a circus act, man. Not from game over, like, if anything, you put money in the hat, because I tend to, get phone calls at 1 in the morning, hey, Peyton, So Matt Smith, who was our head athletic trainer, I saw that they had a graduate assistantship posted for Auburn, and I was looking to do biomechanics and stuff that I really wanted to do. And I said, do you know anyone at all? Because that's a great question for you guys. Do you know anyone? Maybe they don't, maybe they do, but maybe they do. So Matt Smith gets on the phone and calls his buddy, who he worked with the Atlanta Falcons for at Auburn. He's the head athletic trainer for Auburn. He's like, hey, what's up? He said, I got a good old, he called me Cooney. He said, I got a good old Cooney over here from South Louisiana, good old boy. Said, you know me? And the gentleman said, well, I don't have any connections to that. He said, but my wife has a brand new assistantship that they're starting in athletic training for doctors. They just started it. Give her a call. So I give her a call, and about 2 seconds into the phone call, she says, where are you from? No, I'm calling Alabama. I said, well, and by that time my accent was kind of moved off, because I got tired of repeating myself. So I started talking more what we'd consider normal. Where are you from? And I said, well, I'm from Louisiana. And she says, where are you from? I was like, well, I'm from South Louisiana. What town are you from? I'm from Delcom. She says, I'm from St. Martinville. Yes! Guess who got the job? This guy. Right? And so after my 4 years at Auburn, got my PhD in biomechanics, I emailed Dr. George. Dr. George, the person who taught the class that motivated me to say that's what I want to do. He was going through thousands and thousands, so he didn't know me from anything. But I sent him an email. I'm about to finish my PhD in biomechanics, and I just want to say thank you for being an influence on my life. You know, I know you may not remember me, you shouldn't remember me, as so many students, and you usually tend to remember the problem, right? So I just kind of kept it to myself. And he said, when you come back into town, let's do lunch. Had lunch with Dr. George, Lucy was there, and we just had lunch and just talked about things. Well, there was an opening for athletic training that was here. I applied for it, and Dr. George retired right when I finished at Auburn. So guess who got to slide in and do what they wanted to do? You know, and who knows, maybe, I'm not saying it is, but maybe, just maybe, in the back of his head, he's like, there's someone that I mentored that knows my ways, that knows what I did, and can carry that on. For, look, I ain't going to, I'm for 20 miles down the road. I'm not going to go anywhere. So, and maybe that wasn't it, but just there was a part of me that felt that it was meant to be. So the point is that, you know, opportunity, you know, they say opportunity knocks, and it's always knocking. You just got to listen for it. You got to talk to it. So why did I do what I did in terms of undergrad? I love sports. Man, I love sports. As a kid, we were high tech. You know, before the internet and all that, we had a satellite. Because we lived out in the country. I really think they still had like, man, I don't even know if we had cable. I don't think we had cable.
Cable didn't pass.
Cable didn't pass. I mean, that was still like settlements on TP. I mean, it was, we lived out in the country. And so we had a satellite. But with that satellite, man, I can catch any game I wanted, basketball. And every night, man, while my friends were like, let's go out, I'm like, go out. The 76ers are playing. Because Andrew Toney, who was a UL graduate, played for the 76ers. So, of course, I watched them for him. And then all of a sudden, Mr. Charles Barkley came, and I was hooked. I was a 76ers fan. I was a New York Mets fan. Huge New York Mets fan. In 1986, my little league team, the Mets. Mets won the World Series in 86. I've been a Mets fan ever since. And I remember mimicking. I had the little Nerf ball. You remember that? Probably annoyed the ever-living heck out of me. Thank y'all for letting me do that. But I would tape a piece of paper on the wall, and I had a Nerf ball, so I didn't break anything. And I would just pitch. And if it hit the paper, it was a strike. And with that Nerf ball, man, I could Nolan Ryan, I could throw curveballs, make that thing do all kinds of stuff. And in my mind, I'm like, yeah, I'm good at that. Nerf ball. But that's the kind of stuff I did. I was a left-footed soccer-style kicker as one of my tasks in Delcom High School. I never played soccer, but I'll watch Morton Anderson, and I'd go out in the yard, and I'd just try to do what he did. I mean, you just play. And so growing up, man, I just love sports. I love analyzing sports. And then eventually I love playing sports. If it had a round or oblongness to it, I'd try it. I did it. I would say, Mom, I want to try something. And bless her heart, she'd go and get me the stuff. And sometimes it stuck, sometimes it didn't. But I absolutely love playing sports. This was the first time the board put his arms up. He was his first year as principal was my senior year. And that was against Livonia as a post corner scorer. Love sports. Love sports. Playing American Legion ball at Teague Field, at ML Teague Field. Playoff game. I photoshopped that to make it seem like I could jump up. But again, what's cool is that without even realizing it, all of the time and all of the activities actually helped me from when I started doing what I do for a living. That's, mechanical analysis of human motion. So why physics and sport? This is having fun. Come on in, guys. Come on in. Come on in. So why physics and sport for me? And I guess it's just kind of like why do some people like Italian? Why do some people like Chinese? For me, the reason I gravitated to physics and sport is one of my favorite sayings. I say at every lecture. Everybody is a genius if you judge a fish's ability. If you judge the ability of a fish to climb a tree, it's going to go through its whole life thinking that it's stupid. Paraphrasing. But the point is that everyone has a specialty. Every single one of you. Now, some of you may not realize it, or have you found it yet, but what if one of you guys was destined to be the greatest ice hockey player ever? Would you have really known? No, that's nice. When do we ice skate? No, I ice skated one time in my life at the Galleria. I'm just like, yeah. So again, every single one of us on this planet has an area of expertise. The game is throwing your line out enough to one day find it. And when you find it, you're going to know it. You're going to know it because you're going to be sitting in class and you're going to tell people, why are you struggling with this? This is the easiest stuff in the world. And they're all like, so why did I gravitate to physics and sport? And the best way I can explain it is because one does not simply pass biochemistry. I made C's in all my chemistry classes. I made C's in all my biology classes. And I'm not ashamed to say it. I got my C in Alcia Torres. She's a biology teacher. She's been around. She taught Lincoln. she's been, they ran 4 score and 2 C's ago. Everything in biochemistry, it seems like it changes every year. Remember what we thought that? Well, that's not. Just the story changes so much in biochemistry. Can't hold on to that. But in physics, the Newton dude, he's been around for a long time, right? No one ever says, remember what Newton? Boy, was he off by a long shot. It's something for me that I could hold on to, that once I got it, I didn't have to worry about kind of keeping up with it. All I had to worry about is finding cool and new ways to apply it. And so for me, that was comfort. So that's why I tended to gravitate. So now we're going to get into some fun stuff. Things and people that I think are just cool. Like just things that I think are cool. And we're going to segue into this. First of all, I think stars are cool. Stars are cool, man. Stars are incredible. There's more stars. You've probably heard this cliche. There's more stars than grains of sand. There's more stars than sounds that have been uttered in human existence. There's a lot of stars. And it's always been fascinating. One of and again, it kind of goes to my theme. Dr. Tyson DeGrasse, who's the director of the Hayden Planetarium, unbelievable astrophysicist. He does NOVA, a black gentleman, unbelievable speaker. In fact, we're trying to get him down here one day. And what he talks about is when he was in New York, he grew up in New York. He said if he'd have saw that, or he saw it on TV, he's like, no way you could have made me believe there's that many stars. Because in New York, you see like Venus, right? And you're just like, there's one star. And then his family took a vacation to the country, and he saw that. And he said it was as if the universe was calling me. And he said, and who knows, if I would have never been deprived of it, then I would have never appreciated it as much as I did when it came my time. So stars. black holes, supernovas. In fact, in class, we have a universe a week in biomechanics because one of Newton's laws has mass. And you say, all right, we're going to have everything outside of where does that stuff come from? Where does iron and nickel and carbon? We talk about how stars are really just nuclear fusion reactors that fuse things into heavier elements. And then how does it get the stuff out? Supernova, man, spilling its guts out into the universe. So literally the stuff that's in your right ear came from a different exploding star from the stuff in your left ear. That is cool. That's so cool. It's amazing. And so this is like big stuff, right? I mean, just big black holes and giant stars. And then we have some super cool stuff on the small levels, atoms. Stuff we can't even know this existed until 70 years ago, even though Einstein predicted they existed. Who remembers this picture in your textbooks, right? I'll tell you something cool about this picture. Spatial relationship between the nucleus and the electrons that orbit around. If that nucleus was the size of a marble, so in other words, I take a nucleus, the electrons that are orbiting it, guess how far away they are? So in other words, if I took an atom, helium, and I blew it up to a marble, that electron that's orbiting is 2 miles away.
Wow.
Can't exactly put that on a piece of paper, right? It's amazing. It's mostly empty space. And then you start like really messing with yourself, like empty space. Damn it. It's mostly empty space. If you took all of the empty space out of the Empire State Building, you'd have a grain of rice. That's how much empty space is in atoms. That's cool. Like, that's so cool. So those are a couple of things that I just think are cool. This dude is cool. This guy is unbelievably cool. So Isaac Newton, he was so famous they named a treat after him. A very famous treat. Look, this is Isaac Newton didn't date. He didn't marry. Hey Isaac, would you like to? I'm trying to calibrate this. You know, he didn't care about anything other than science, just answering questions. And you know, I love these memes. Isaac Newton developed the use of calculus at the age of 26. 26 years old. You know what I was doing when I was 26? Ordering from the 99-cent menu at Burger King. And Newton is developing over a dare. So someone asked him, they're like, oh, are you so smart? How come these orbits take elliptical patterns? You know, can you explain that? He knew it did, but can you explain it? And he was like, be right back. 2 weeks later, he comes back with calculus and explains how the ellipses happen. He also really understood, and I think this is fascinating. I just think this is cool. When we see the Earth, and in Mathematica Principia, he has this in his writings. He explains how the moon, that we see the moon right orbiting, really is a falling. The moon is falling to the Earth. The sun, the Earth is falling to the sun. And he drew this really cool diagram. He had this little cannon, and he drew a little planet. He had this little cannon. And he's like, you know, if you shoot the cannon, and it's going to fall to Earth, it's going to take a curvilinear path, right? It's going to hit the ground. But if you put a little bit more velocity, it's going to go a little further. And if you put more velocity, it's going to go a little further. Until you shoot it with enough velocity that it misses the Earth. And it goes all the way around and hits you back upside the Earth. He used, this is back in the 1500s, he used, and so there's the little gun, and he used the little drawings, and he says, if you shoot a projectile with enough velocity, it's going to fall, but the speed of that object is so fast that it just misses. So when you see the moon, that moon is falling to the Earth, but it's moving so fast around it, it keeps missing. The Earth is falling to the sun, keeps missing. The sun is falling around the supermassive black hole that's in the center of the Milky Way galaxy, but it keeps missing. That's pretty cool. This dude figured that out. Like I'm like trying to figure out like basic algebra, and this dude's drawing little guns and planets. I think that's pretty cool. And then Einstein came along, and Einstein is cool for a few things, but Einstein worked in a patent office. What a brilliant place. Because he got to see all the designs, and he got to see how everything worked, and he got to see the blueprints. This was in the age of light, when people started to realize, light didn't get shot from our eyes. Light is something. Light has speed. And so he was fascinated with light. And some of the questions, and he would do Sitch Life, it was like a thought experiment. He would literally think out logically these concepts. So here's the example. He said, well, what if I was traveling in a car, right, instead of bus, and for all of a sudden I was going the speed of light. The light, and I look back at a clock, and that clock says noon. If all of a sudden that light that reflects off that clock and is coming towards me, and all of a sudden travel the speed of light, it would always be noon. Because nothing else would ever catch up to me, right? So that was just one of the many, many, many things. What he took a leap that was so amazing. They knew that light, and this is kind of weird, light travels the same speed for all observers. It's kind of weird, because if I take a ball and I throw the ball 80 miles an hour, okay, that's not going to happen. 40 miles an hour. If I take a running start and I still throw it 40 miles an hour, it's going to be 40 plus whatever I'm running at, right? It's not. It's going to get a little extra push for me running. That's not how light works. If I take a flashlight and shine the light, 186,000 miles per second. And if I take a running start and shine the light, 186,000 miles per second. Light travels the same speed for all observers. So what Einstein, now granted, they confirmed it. They did the studies to say light travels the same speed for all observers. So what Einstein took the next leap, he knows, you know what speed is? People, you don't know this. It's how far you went and how much time it took you to get there. Right? And simple little equation. How far did you go? How much time? Place and time. Anybody ever heard of space-time? Right? The word space-time. I mean, think about it. It's not illogical. If you're going to meet, like say for tonight, you need two things. You need place, but a place isn't enough. What do you also need? You need a time. We're going to have a meeting. Okay, where are we going to meet? And when are we going to meet? Those two things are married together. A place and a time. So this is what Einstein believed. And again, think about this. This is the early 1900s. He said the only way light can be the same for all observers is if space and time allowed it to be so. And that's when you literally have warping of space and time. Everyone's clock is different based on your relative speed. That's why the GPS systems have to recalculate each other, because based on their speed, their clocks will be a little different. And they've done this experiment. They've taken jets and flown them over the Earth over and over and over and over. And when they've come check their clocks, they're different. They're different. This dude thought of that in the early 1900s. It's absolutely diabolically crazy. And so what he did that Newton couldn't. Newton understood there was gravity. He understood that it was there, but he didn't understand how it worked. He didn't understand how it worked. How does gravity work? And that's what Einstein postulated. And what Einstein figured out, in Newton's fixed model of space, Einstein, brilliant observation. He did a thought experiment. He said, what if? We've done that before. Just what if? What if this would happen? This is what Einstein did. So in Newton's world, gravity literally held on to things. Literally, the Earth held on to the moon. No how, but it had to hold on. In other words, if the Earth disappeared, its influence on the moon would disappear. So this is what Einstein did. He said, okay, well, if that's the case, we know that the sun, light takes how long to reach the Earth? Do you remember? Yeah, about 8 minutes. So in other words, light that leaves the sun travels 8 minutes. We know light travels fast. Einstein did this so simple, so elegant. He said, what if the sun just disappeared? Just poof, disappeared. In Newton's world, immediately the Earth would take off because there's nothing there. But Einstein knew it would be 8 minutes before we even realized the sun disappeared. We would still have the sun for 8 minutes. That's cool. And it goes into the warping of space and time, because again, space and time is one thing. You gotta have a place, you gotta have a time. And so when he postulated that if the sun disappeared, the wave of gravity would take 8 minutes to get here. And when they calculated it, those things match up. So gravity in itself isn't instantaneous. It's the warping of space. When you were growing up, I love this, where you put the coin in and you watch it roll around. I could literally just do that now. Just start watching it. That's how objects with mass, that's what gravity is. So objects with mass warp the space around it. And what we perceive as things free-falling are really just coins spiraling around. They think they're moving in a straight line. They have no clue. The moon that's spiraling around, now again, this is a two-dimensional image for a three-dimensional concept, but that moon is just around. The moon is like, I'm going in a straight line. You ever seen the motorcycles go in the little ball? That's how it is. The motorcycle thinks, I'm just going straight. Oh, come on. But the warping of the ball changes direction. That's really cool. So how did they prove this? Einstein postulated that if you take a photo during a total eclipse, you're going to see a star that's not where it's supposed to be. Because as the star comes close to the sun, that light, thinking it's moving straight, will be redirected by the warping of the space. And so you're going to think it's there, but in reality it's there. This is what, again, fate, God, whatever you want to call it. What just so happens to be the moon, which is a lot closer than the sun, when it lines up with the sun, it totally blacks it out. Perfect. And so these astrologists did the experiment. Shot the pictures of a total eclipse where they can actually see stars that you normally couldn't see because the sun's so bright. And there it was, exactly how you predicted. So he proved that mass warps space, and that's how gravity works. It's kind of cool. So this Newton guy, right? He had these three observations. They call them laws, but I like to look at his observations of human movement. Some of them deal with motion, some of them deal with force. So this is kind of some of the stuff I love to talk about in my classes. His first law, or his first observation, is the law of inertia. Right? And all that means is that objects, you know maybe the 50-cent definition, object in motion is going to stay in motion, object at rest, stays at rest, unless I get blah, blah, blah. In essence, an object's going to resist change in its motion, regardless of if it's moving or not moving. It's just going to resist change. The object's very conservative. It's not going to change its motion unless something changes. Sumo wrestlers, big people, little people, big people, because they want to resist change in their motion. And I say offensive linemen, big people, little people, big people, because they want to resist change in their motion. And again, it doesn't even have to be to speed something up, to slow something down. A train can't just slam on the brake and it's all right, it takes a while. So the first observation that Newton made was this observation of objects with mass and their resistance to change their motion. The more stuff they have, that's another word for mass, the more they're going to resist change in their motion. I've seen some, teams that are back in the day, offensive linemen back in the NFL, they're like 250 pounds. And they're like, wow, we get them bigger. They can resist more change. So, not one of those evolutionary things. But big people. First law applied to sport, and this is a hot topic with concussions and football. The analogy that I like to use is, just swapping out the parts. When you're driving in a car and your car stops, everything in that car will keep going until something stops it. Again, resistance to change in object's motion. So the car, your head, if you negatively accelerate with enough force, that airbag's going to pop out and eventually slow you down. And so if your brain is the passenger, the fluid and the stuff inside your skull is literally your airbag. That's what's there to slow you down. You try to fluid, but sometimes those impacts are so hard. And again, especially for what we're seeing now in chronic athletes, it's not so much the one big impact, it's the cumulative little hits. I say, one of the analogies I use is if I tap you on the arm, it doesn't hurt. This is 1,000 times in a row. Eventually, it's going to hurt. Right? So it's similar. Sometimes you hit that airbag and you can cause trauma right away, but sometimes it's just a repetitiveness. And the athletes, especially the older NFL people, see them scar tissue and stuff, because your airbag is not literally an airbag, it's more of a fluid bag. And the head really wasn't meant to do. Now, I'll tell you this, in high school, let's just think logically. High school, I thought, I remember Melissa, used to ask me, she said, well, Brian, you ever thought about playing college football? Man, I didn't really like, I love basketball, I didn't really like football. I was like, no, when I came to UL, I was an athletic trainer. And we had the worst team in the country at the time. We really did. We went, that was when Washington State beat us 77-7. It was 35-0 after the first quarter. They had players playing that didn't even have a name tag. But I'll tell you this, the worst athlete on that team was a better athlete than me. So when you think about the impact, pee-wee kids, this pee-wee said, little kids, and they're moving slow. They might fall on each other. Little kids moving slow. But when you get to the college level, bigger kids moving fast, and then imagine the next leap, the pro level, where you really call the herd. They only invite like 270 players from college to even do their combine. That's how selected they are. Bigger people moving faster. Those impacts are just absolutely, it's mind-numbing to think of some of those repetitive impacts. The second law, the second observation, this is the one right here. Dr. Nels Madsen in Auburn, Alabama. Wendy Weimer was my major professor, but we called in, he loved sports, he loved activity, but he was an engineer, he was a dean of engineering. Dr. Madsen, glasses, 6'3", rode a bike to school, like with a basket. I mean, just like typical nerdy. I loved him to death. He'd ride his bike every day, and hey guys, how's it going? But on the basketball court, he could ball, man. He was so good. You don't think, oh, I can take it. You do this one. An engineer. And he's like, now this guy was responsible for Gollum. In Lord of the Rings, his motion capture software created Gollum. Dude has Academy Awards. Thank you for the Academy Award. Motion capture stuff. And you know what he used to say in class? I think sometimes he just tried to make us feel better. He's like, this is all I do. I just apply this because this is everything. Newton's second observation took mass, which is a measure of inertia, how much stuff is in an object, and he just looked at cause and effect. And said, okay, well, objects, every object, your pen, you, the desk, the ball, the helmet, everything has stuff. And we know that that stuff is going to resist change in its motion. Well, the logical question is, what's trying to change it? It resists change, but something must be trying to change it if it's resisting something. Like peer pressure, right? I'm resisting peer pressure. Well, what's peer pressure? What's pressuring you? So in that regard, all Newton did was make that leap, that objects with mass, things outside of the external influences, he called it, forces. There's different kinds of pushes, pulls, frictions, gravity. All this external stuff, I like to think of it as peer pressure because there's external influences trying to make you have a big test the next day. Someone calls and says, let's go out. Well, man, I have a test. I don't want to change my motion. But the larger the external influence, oh my God, dude, so-and-so's going to be there. Everybody's doing it. The larger that external influence, the more proportional you're going to get your booty up and go and move. So Newton's second observation is really, it's the tie that binds. It's the direct proportionality between unbalanced influences are directly proportional to objects. All objects have mass, and those objects' acceleration changes in motion. It's really cool. It's very profound. So Dr. Madsen, that's all I do. That's all I do. And again, the sum, that's what's really important. Not every force is going to cause something to accelerate. The sum, it's like balancing your checkbook. You have some checks that come in, it's positive. You have some checks that go out, that's negative. And it doesn't matter. You could get $1 million. But if you spend $1 million, that's the same change as if you brought in $10 and spent $10. The change was the same. So that's why you got to add in all the different influences that are trying to influence you, negative, positive, and whatever that net is, whatever that remainder is, that's what's going to be directly proportional to the acceleration. It's cause and effect. God, I love this stuff. Look at that golf ball. And I used to think this. I used to think that when someone hit a ball, it was instantaneous. It's just instantaneous. Look at the ball literally jumping off. You could literally visualize that ball as having legs. And when the club impacts it, it leaps off of the club. The ball literally has legs, and when the kicker kicks it, the ball leaps from his foot and goes. But as a kid, I was like, that's instantaneous. Anything that changes speed instantaneously is magic. It's magic! Everything takes time to speed up and to slow down. The problem is that our eyes can't process it. Right? That's why the magicians have the advantage, because our eyes can process only so many frames per second. So when you think that the ball leaves the bat instantaneously, it doesn't. It slows down in one direction, changes direction, and then speeds up. It's just our eyes can't process it. Everything takes time. So what is acceleration? Speeding up or slowing down is the easiest way. And we know that nothing can speed up or slow down in no time. The analogies I like to use in sport, everything takes time to change position. Who remembers Reggie Bush, right? Reggie Bush for the Saints? Before he actually learned how to be a running back? It's like Reggie Bush, he used to drive me crazy. He'd get the ball and he'd go one way, change direction. Like, just give it to Deuce. Deuce goes that way, right? So Reggie and I ran 30 yards, but he only gets credit for how far he went that way, right? So in essence, a 40-yard dash. I like to look at the 40 because people know, or a 100-meter dash. Imagine if we just said, if we just looked at displacement, that's just change in position. How far did you go? Imagine if that was our only outcome. Let's just pretend. So someone says, Brian, you ran the 100? Absolutely, I ran the 100. How'd you do? I finished it. Now that's different if we're running a marathon, right? I finished it. Woo. But 100, I finished it. So in other words, if we just looked at displacement only, how far did you go? Everybody would tie, unless they pulled out, I didn't finish it. You hurt yourself. So what do we have to separate, to put people on a continuum? We have time. That weird thing, man, it's just hard to understand. It's hard to define. It's something that my son knows. I don't know what time it is, but time is really hard to define. It allows us to slot things. It allows us to put things in ratio of order of events. So if you said, well, how much time did it take you to displace? And someone says, well, I ran it in 5 seconds. I ran it in 4 seconds. Again, we don't know physics. I didn't know physics. But you know intuitively that the lower the number, the faster you had to go to finish it, right? Because we're all displacing the same. Whether it's a 40, whether it's a 100, whether it's a 200, we're all doing the same on the top. So any variation on the bottom insinuates who was moving faster. So let's just go right there. Speed, that's what speed is. How much time it took you to displace. And I like to look at acceleration as a gumbo. It's made of stuff mixed together. We call it a gumbo, but the gumbo is made of different things. Acceleration is something, but it's made of different things. So we have velocity, which is part of acceleration. That's like a root, right? We made something, it's not a finished product. So then imagine this. If we just did velocity only, how fast did you go? How fast can you go? The analogy I use with my class, I'm in a car, my 1993 Honda Civic. And next to me, I'm talking to a gentleman that owns a red Maserati. And he says, my car can go 100 miles an hour. And I say, well, that's pretty cool. My car can go 100 miles an hour. I'm not lying. Well, let's test it. He gets in his. I get in mine. Now, again, if we just did it off of who can go 100, I'm not saying how long it's going to take me to get there. So that's the magic of acceleration. How much time? You know what it is? You taste the gumbo and say, it could use something else. It could use more time. We put time in there again. How much time does it take you to change your velocity? They say this on TV, 0 to 60 in 4.3 seconds. They are insinuating, just like we insinuate velocity, they're insinuating acceleration. How much time did it take you to change your velocity? That's what acceleration is. And why is that concept important? Because unbalanced forces influencing objects cause those objects to change velocity. And nothing can change velocity in no time. Everything takes time to change your velocity. Even when you slam on the brakes, that takes time. Even when the golf ball is hit by the golf club, it takes time for that golf ball to be compressed and then literally to leap off the club. Everything changes velocity in time. Second law applied to sport is everywhere. It's everything. Like Dr. Matson said, all I did was apply the second law to everything. Momentum Impulse, things you might have heard in high school, that's derived from Newton's second law. You just move around the ingredients, next thing you know, you got a sauce piquant. I mean, it's just changing around the variables. But impulse and momentum all derived from this. All the little equations where how can we calculate, it's all derived from Newton's second law. Everything. That's pretty cool. Okay, if you're squeamish, you really got to look at some of these. Newton's second law applied to injury. I know it happens. It happens. This one, I remember this game, Tyrone Prothrow. How many of you, the ankle braces, right? You know, they used to have the, well, be careful what you wish for, because by limiting motion or wounding, that force got to go somewhere. And so it would go up the chain, and then where the brace is, that's nice and sturdy, acts as the fulcrum for the fraction. That can happen. And sometimes just bad things happen. And it can be bone cyst, weak spot, wrong angles, but influences can sometimes be a bad thing, especially like say in NASCAR, where they got the cars moving so fast, they had to start putting limitations. It's going too fast. Turf. Remember when turf came out, the field turf, the first time? It was too good. People were running too fast. Their joints couldn't handle that stress. They put field turf, little bits of it. So sometimes the technology is too much. I remember my mom having a racket that was made of wood, right? Pancho Gonzalez or something like that. I'm like, wow, this is cool. And then that belongs in the Smithsonian now because of the technology that's on the back, right? Third law. This is my son Tracy, who is 6 years old, and I love listening to him tell stories. The third law of Newton gets misconstrued a lot. It's not an action-reaction thing. It really isn't. Because that would insinuate, anytime you think of the director saying, and action, doesn't that insinuate motion, right? Okay, move, go. It's not action-reaction. Things don't have to be moving. What it amounts to is force counterforce. Like, I'm applying Newton's third law right now. Doesn't mean I'm moving. But I love this story because it was so pure. Trayson one day was talking to me about ghosts. He might have been 4 years old. And he said, Dad, I'm afraid that a ghost can come and get me. Right? I said, well, if a ghost comes and gets you, just punch him, fight him off. He said, well, no, Dad, that's not how it works. You know, because the ghost, if I try to fight, I'm just going to go through the ghost. Ghosts are clear. Right? And I said, Tracy, it's impossible for that ghost to touch you without you being able to touch him back. And he said, let's play soccer. You know? But think about that for a second. It's impossible. How can the ghost contact you without you being able to contact it back? It's impossible. That's the essence of Newton's third law. It's impossible for two objects not to feel each other. If you touch the desk, it must be touching you back. If you touch the ground, it must be touching you back. If I don't touch the ground, it's not going to be touching me back. And their influence is married together. If I barely touch the floor, it's going to barely touch me back. If I touch the floor a lot, it's going to touch me back a lot. That's what Newton's third law is. It's a force counterforce law. For every influence one object feels, there's an equal magnitude opposite direction counter influence some other object must feel. It has to. It's impossible for it not. It's impossible. So I always think of ghosts when I'm applying Newton's third law. Love that story. Newton's third law applied to sport. We've got some volleyball players here, right? Okay, so I thought I'd put some volleyball. This is for class. When we go over this, guys, you don't move yourself. And it's weird. It's like, well, what do you mean I can't move myself? You don't move yourself. If you were in outer space and you didn't have a jetpack, you can do this all day long. You're not going anywhere. It's weird. Because you think, well, no, I'm moving myself. You're not moving yourself. Your environment is moving you. When you swim, the water is moving you. When you walk, the ground is moving you. Now, lucky for us, we get back from the ground what we put into it, Newton's third law. But in essence, you know what's cool? You know, sometimes losing is a bad thing. But sometimes losing is a good thing. Every time you push off on the ground, you lose. Because in essence, you're trying to move the ground. The ground's not going anywhere. So in essence, you lose. Woohoo! But think about playing. Y'all ever play beach volleyball in the sand? Anybody? I'm embarrassed to play beach volleyball. I don't get embarrassed. But that's a good example. It's still your muscles. It's still your motion. But you don't get near behind there. Because when you go to push on the ground, you win. And the ground gets moved. So you are a function of your environment. You don't move you. Your environment moves you. And even air is stuff. There are molecules in the air. When you run, the stuff you feel is stuff. That's really, I think that's true. But not as cool as friction. Friction is super duper cool. And this is going to segue into some football stuff. Friction is unbelievably cool. Friction. Here's mountains, right? Big mountains. If you could hold the earth in your hands like a basketball, it would be smoother than a basketball. You wouldn't even be able to feel Mount Everest. But we know there's imperfections in the earth. Hey, look at Jefferson Island. Because here's everything's flat, right? We're like one hill. There's imperfections everywhere. There's imperfections in the carpet. There's imperfections on the wall. Again, we can't perceive it. We perceive a surface as being smooth. It's not smooth. If we zeroed in with an electron microscope, it would look like the Andes Mountain. So what happens is when two surfaces are compressed together, we need two surfaces. The imperfections in one surface interlock with the imperfections of another surface. And then when those two surfaces try to move perpendicular to the compression, you literally get a microscopic push from those little teeth, from those little imperfections. And this is what I think this is super cool. When you go to grab a sack of crawfish and it's slipping from your hand, what do? You compress it more, right? You interlock the imperfections between your hands and between the sack. You ever thought of this? Your fingerprints are the same concept as the grips underneath your shoes to create imperfections. That's why your fingerprints is to create grooves, to create teeth, to create interlock. And roughnecks and people with rough hands have great interlock. I have like dish pans with interlock. That's so small. It means a lot. Right? People shake my hand and be like, dude, what's that hammer? You know, like, that's true. But this is the same thing. It's the same thing. It's to create interlock between the two surfaces. Now, friction is really important, more than we even realize to sport. And friction's not easy. Ask my biomechanics team. Because we don't see it. We can see push, heck, we can see pull, but friction's the micro. It's there, is it there? Is it not? So one of the questions, in just shooting the breeze, I'd love to start this conversation. Why are quarterbacks tall? And you're going to get some cliche answers. Well, they have to see over the line. Doug Flutie played in the NFL. He's 5'9". Drew Brees isn't exactly the tallest guy in the world, and I don't see many of his passes. He has like a 70% completion rate, right? Drew Brees is one of the all-time completion percentages in the NFL's history. Well, so the passes don't get bad now. Well, we get Drew Brees is small, so the see over the lines. You ever play with a Nerf ball? You know the Nerf football? I'm Joe Montana with a Nerf ball. Dude, a Nerf ball? I get an NFL ball in my hand, and I'm like, woo. Shaquille O'Neal, 7'1". He has 7'1" hands and 7'1" feet. Usually, not all the time, but people tend to have proportionality based on their height. But there's exceptions. There's always exceptions. There's always anomalies. And I'll show you one right now. Well, let me get into friction. So I want you to read this. If friction from the fingers to the ball is insufficient, well, you can tell it's late last night, I apologize. Is insufficient when the ball is speeding up, and the ball will stay behind, just like the vase, the wine, the glass will stay behind, as you pull the tablecloth, right? Anybody ever try that at home? I did it one time and one time only. They weren't there, but I did try it. It wasn't expensive stuff. But think about it. When you pull, when you create, when you speed that tablecloth up real fast, there's insufficient friction to also speed up the stuff that's touching you. So imagine, guys, you know what I'm talking about. If you've ever tried to throw a ball as far as you can, and you don't have sufficient friction, that ball's going to slip out. Just like in this scenario. So what creates friction on a football? What are the two surfaces made of? The interlock, that's why you have the little bumps in the football. That's why you have your fingerprints on your hand. But the compression. And a football is not small. So again, you look at a child holding a football. How can they create some sufficient compression, right? If they try to squeeze it, that ball's going to pop out. So what creates friction on a ball? Big Shaquille O'Neal hands. Big hands. So logically, taller quarterbacks usually have big feet, usually have big hands. You ever shake Jake Delhomme's hand? Big hands. Brian Saunier, who played quarterback, big hands. I put my hand up to him like this. So you're like, well, what about Johnny Manziel, man? Johnny Football. Johnny Football is 5'11", 6 foot. But read that quote. Dude has size 15 shoe. He has huge hands. Doug Flutie, huge hands. I shook his hand. In fact, I felt like a geek. I'm like, there's Doug Flutie. I want to see how big his hands are. I'm like, wow, I can't wait to see his hands. Big hands. Because you need big hands to create friction on the football. You don't need big hands to push behind a baseball. Because you're pushing behind the center of mass. That's why Tim Lincecum, you can have small people throw hard in baseball because you're not limited to the friction. Johnny Manziel has huge hands. Drew Brees.
Johnny Unitas.
Johnny Unitas had big hands. Dad and I got to meet him in Baltimore, shook his hand. In fact, that was the first time someone ever referenced, I was 15 at the time, a quarterback with big hands. So, who's the guy on the right? Russell Wilson. 5'11", not a big guy. Who's the dude on the left? Big man, 6'5". When they shake hands, they got the same hands on. Anomaly. There's nothing written in genetics that says you must be proportionate. Drew Brees gripping a football can compress the two surfaces. Brian Campbell gripping a football is going to pop out there. Believe me, I've seen it happen many times. Another cool thing about sport is how does a quarterback or baseball player generate maximum velocity? It's also for volleyball too. And the secret is that shoulder external rotation. Imagine if you were going to shoot peas at your brother, sister, cousin at the dinner table when no one's looking. The further you bring the spoon back, the faster that pea is going to sling, right? So the cool thing about these people, whether it's volleyball players, football players, baseball players, is that their catapult, their spoon that's going to sling it, goes back further than the average person. Our range of motion is the same, but the window is different. So in other words, Tom Brady can make his spoon go back further, but his range of motion stops about right here. Me, I can't go back very far, but I can go all the way over here. So if there was some Olympic sport to throw something behind me, I would medal. Five-time medalist. The problem is I got to go back, right? And this is it. And I remember Dad and Mom remember this when I was younger. Before I hit puberty, man, I could throw relatively hard. I mean, compared to my peers. And then logically, I was like, well, man, this is great. Because as I develop and get older, I'm going to be able to throw harder. I'm going to be working out for harder. And then all of a sudden, one year, I'm like struggling to reach the pitcher's mound. I'm like, what was that? I've been working out. And then when I learned about mechanics, and I'm like, oh, into the road, okay. Into the road. That's an unbelievable amount of external rotation. Watch this. And it's an illusion. He actually goes further than what you even think because his trunk is leaning forward. So his external rotation actually goes further than 90 degrees, back. How come we never notice this? Because once again, our eyes can't process that many frames per second. If you watch baseball, I want you to play this game called Follow the Ball. I can follow it, I see it, I see it, I see it, I see it. It's a blur. Because the external rotation followed by the internal rotation is too fast for our eyes to process. We gotta slow it down. But isn't that incredible? And that's not even a fastball, that's a slider. I could literally watch that all day long. Like I'm serious, to me that's like the Sopranos. Like Sopranos season 1 through 8, like that's me. I'm just like eating popcorn, like that is absolutely incredible. All day long. So let's look at some others. And you can't cheat. So you're like, I can make my shoulder do that. Like bowler, right? No, you gotta just do it in your shoulder. You can't cheat with your scapula, you can't cheat with your trunk. In anatomical kinesiology, we call it our functional range of motion or functional window of reach, where you can use other joint motions to kind of cheat. It's no different when you're stretching. Like someone's trying to take your foot across and you're like moving other things, just to make it go across. Okay. Let's watch Lincecum. One time, slow motion. And again, you can't see this. Watch how far back. Watch this. Watch how far back his shoulder externally rotates.
Wow.
Wait. Now he's prepping right here. You know what it's like? It's like a wrestler that runs into the rope, and the faster he goes one way, the further the rope's going to swing back. So now the wrestler's running to the rope, and the rope is getting stretched, and that wrestler is maximally. Look at that! That's unbelievable. That's how a 5'8" person can throw 95 miles an hour, and it's a rare commodity. That's why some pitchers look like they just got out of Hainan, right? All you can eat buffet. Be like, how is that guy an athlete? He's slinging peas, man. His catapult goes back further than everybody else. It doesn't matter what he's eating at Hainan. His catapult goes back further than the average person. That's the secret. That's the magic. That's the magic. Here's another cool thing. When I say it in class, people are like, no way. Guess what? Everyone throws sidearm. Because sidearm is a relative position. We think of it as being a global position, throwing overhand, throwing sidearm. But it's relative to your shoulder angle. So everyone throws sidearm as mechanically, that's optimal for maximum velocity. If you were in a thing that spun you around, right? I don't know, what's something that spins you around? There you go. If you were spinning around as fast as you can, I don't think your hands would do this. Your hands would go out. You get maximum velocity. Another way to look at it that I try to explain is if you look at a record. Kids, do y'all know what a record is? It's this little black thing, you put it on, a little diamond thing. If you look at a record, you take a record. We're going to take a silver Sharpie because records are mostly black. And we're going to take a silver Sharpie, we're going to draw a line from the center to the edge. And I know logically that one revolution around, every point around that silver line is going to cross the finish line at the same exact time. Does that make sense? It's going to revolve, and the person on the inside lane is going to cross the finish line the same as the person on the out lane. Who's running track? Who has the advantage running around the track? The inside lane or the outside lane? The inside lane, right? So if I got to go all the way around the track, and I have to finish at the same time as the person on the inside lane, who's got to move faster? The outside lane. It's the same logic. The further you are away at your release, the faster that son of a gun is going to go. Because that's the outside lane. That's the passing lane. So everyone throws sidearm because mechanically it's advantageous. So what we perceive as overhead or sidearm is really a global concept. In other words, if I'm trying to throw overhead, I'm going to lean my trunk, but I'm still throwing sidearm. And even a submarine pitcher throws the exact same way as an overhead pitcher. They just reposition their trunk. It's the same. Remember Vince Young? People said like Vince Young throws like Uncle Rico. Remember from Napoleon Dynamite? Vince Young, he throws like Uncle Rico. Vince Young throws like everybody else. But he kept his trunk straight. So for him, it literally looked side on. All the other quarterbacks lean their trunk. But they're doing the exact same thing. The only difference is they're lean. Tom Brady, lean. Little league kid, throwing sidearm, leaning. Notice the trunk lean. Same relative position. I think that's pretty cool. Those are just a few things that I think are cool. Man, I debated, man. There's so much fun stuff to talk about. How do curveballs work? You know, the natural lefty curve. I was a left-hander, right? Natural lefty. It's an illusion. So I put in just a few things, kind of like a drug deal. Just samples, right? I want to talk about some more stuff. So now it's where we open it up to questions, and this doesn't even have to be physics. Career options. You know, kinesiology. What is kinesiology? One of the reasons we want to do this is to promote kinesiology. What do we do in kines? You know, we have 5 different major concentrations. The largest being exercise science, which is what I'm the coordinator of. But we also have athletic trainers, people that help others in athletics. Guys, athletic populations are different than normal populations. You know, when my aunt gets hurt, it's not exactly her rehab isn't accelerating. You know, it's a little bit more conservative. But an athlete, you got. This is what I tell people too, and people that work with occupational people and occupational biomechanics. In athletics, man, we can push that envelope. You know why? Because we have a bench. There's people that are there that can take their place. There's no one in a work setting, right? That's, you know, they're working at the Tabasco plant, and someone's sitting on the bench going, "You're doing great. Let me know if you need." There's starters. In the workforce, there's the starters. There's no bench. So if someone gets hurt, you not only have to pay the starter, but then you got to pay the backup. And so they're a little bit more conservative in terms of occupational biomechanics. We call that ergonomics. Trying to adapt the work setting to the person, not just throwing the person into the work. So those are jobs. A lot of our students do physical therapy school after, occupational therapy school, physician assistant, respiratory therapy, pulmonary therapy. Our coaches are from kinesiology. Our athletic trainers are in kinesiology. Pretty much anything in allied health, there's just so many options. I learn of new careers every day. Wow, somebody does that for a living? Because the bottom line is, when you get a job, you like to enjoy what you do. But you also like to get a job. And so these graduate programs in PT, OT, physician assistant, respiratory therapy, med school, they only put out so many kids a year. And guess what's happening to the human population? Going up and up and up and up. And that delta is called demand. And so what I tell students all the time is that if you come into kinesiology and after a couple years you say, "I changed my mind, I want to do engineering," bless your heart, good luck to you. But if you come into kinesiology, you don't lose time if you say, "Well, I thought I wanted to do physical therapy, but now maybe I'm looking at physician assistant, maybe I'm looking at med school, maybe I'm looking at respiratory, cardiac rehab." Have you ever noticed there's a heart hospital every few blocks around here? And they will hire people. So what's great about our area is that as long as it's in the allied health area, you don't go back. You don't get in the back of the line. We put you in a position to get all your prerequisites so that way you can apply even to multiple graduate programs. That's kind of cool. So after, if you guys want to hang around and talk options, I don't mind. Any questions in general about physics, sport, or yes, ma'am?
I have a physics question. You said that
Where's my wife?
you said quarterbacks have big hands and their fingerprints with the ridges help them to hold on to that ball better. But yet when I watch them on Sunday, they lick their hand before they put it on the ball. Does that fill the holes?
Not to an extent, because what you gain and what's considered a disadvantage could also be an advantage. So what they're licking away is dirt. So dirt can also fill the hole. So like if you ever notice when I used to play basketball, when you play on a court that hadn't been swept, those little dirt particles fill in the imperfections, right? So those players, they get dirt, they get mud. So for them, the cleaning away the dirt is more an advantage than the few little saliva particles. That's a very good question. So that's what they're doing. They're literally cleaning it from the dirt, because dirt can also be, it's very disgusting. Absolutely, highly disgusting. But again, dirt can make you slide. You know? If you slide, you slide. So there's no reason. But it is kind of gross, especially when you consider where their hands have been. I'd have like my quarterback towel and a thing of Purell. And I just rinse, repeat, man. I just keep doing it.
Damp the towel so they can wipe their hands.
Absolutely. Yay, Bristol.
Never kiss a quarterback.
It's a good quarterback. I want a quarterback.
So obviously you can see that you have a love and a passion for this. So like, what do you think about in terms of this? Because like my mind doesn't even think these kind of thoughts that you probably.
But there is something that you do give a lot of time and effort to think about, or something that you just think and be like, that's cool. So it's all relative. It's just whatever you find in your wheelhouse. And again, when students, and help me if I diverge too much off the interstate, students I'll ask them this question when I do advising. So what do you want to do? And you know what's one of the best responses I can get is, I don't know. It's a great answer. Because that just means I'm not going to just say something because I feel I have to. And really what they want to say or what I don't know yet. Absolutely. That why word is. So in other words, everybody has some type of interest. And for me, I just happened to luck out and found the stuff that I could get. I didn't even know it was out there until, again, I stumbled open to that door, and then that door opened the door, and that other, and I'm just like, whoa, look at this room. Now, it's like when I used to go to Sears when I was a kid, and be like, man, here's the washers, here's the toy! Yes! But you always had to, like, luckily stumble upon the toys. You know, it's just different levels, different floors, you know, where it was, they moved it around just to mess with it. So it's two different forms of the same thing. We really have the exact same passion. It's just maybe what we're passionate about might be a little different. But it's all the same. You know, my father loved my mom and dad to death. My mom's the fisherman. She loves to fish. You know, my dad's the fisherman. Loves to cast. You know, he'll be like, man, Chad, we went shrimping the other day. You should have seen that. Just joy, sheer joy. And I'm like, Dad, that's great. But for him, man, that's right. And he can tell you all about it. In fact, Dad could be called as an expert witness in court. You know, I'd like to call upon the next expert witness, Pat Campbell. That's how much he knows, because he enjoys it. Now, I'll tell you this, for the high school kids that are here, and by the way, that says so much about you guys, just the fact that y'all are here tonight, so hats off, metaphorically, to you. But it goes to show, God, I lost my train of thought. It goes to show your interest. When you have an interest, you really have two different forks. You hear this cliche, you want to do something that you're going to love for the rest of your life. You hear that a lot, but that's not necessarily always the right thing. You know what you need to do? You need to find something that's going to support you in the lifestyle that you want, especially ladies. When I advise, so what do you want to do? Well, my boyfriend's going to do something, and so I really don't need. Yeah. You need to find a career that's going to support you. You don't need to rely on the man. And men, it's the same thing. You rely on yourself. Now, obviously, it would be nice if that area happens to be something you love. But ultimately, you're going to need to find something you can tolerate first. You know? Because anybody can find a job. I can go right now and work at a restaurant, and there's nothing wrong with that to help, you know, but can you find a career? And that's what I think we really go above and beyond to do, is try to introduce you into all different kind of careers. You know, guys, y'all were a little late, but I said, you know, when I was growing up, I thought there was 5 things a person could do. You could be a policeman, a fireman, a teacher, a doctor, you know, just the cliche jobs. And as I got older, man, there's so many cool careers out there that you haven't even been introduced to. So I look at it as my job is to try, I don't know them all, but when I find out something, I'll introduce you to those things. We'll open up doors together and say, look at all this. And it's another thing we try to promote within kinesiology too, is attending these conferences and conventions where, don't take my word for it, I'm limited in my knowledge of the evolution of careers. So by going to these conferences, and we learn about new careers and new options, or even new applications. Like, did you know that physical therapists can work as physical therapists with animals? You can do therapy on animals. Physical therapists that work with animals. That's cool. You know, well, I don't really want to be a vet. I love animals. You can be a physical therapist that works with animals. You know, like, that's the kind of stuff that I'm talking about, is not just necessarily a job, but the application of all these different jobs. Like occupational therapy. You know what a child's occupation is? To play. That's their job. So occupational therapists work with children. What's an older person's occupation? To function, right? Activities that they live in, to be able to cook, to be able to, that's their job. So again, it kind of, to whittle through the cliche and really look at all these different settings that you can even work in too. It's like, wow, I didn't even realize that I could work in that setting. Game on. And then once that fire is lit, once that motivation is set, it don't matter where you started, it don't matter what was behind you. When it's lit, it's lit. I didn't finish in the top 10 of my class. In Delcom. I finished in the top 10. Dad finished higher than me, right? You finished?
I finished in the top 10. There was none in my graduating class.
And he still holds that over you. But that's what's cool. It don't matter where you started, Jake. Once that fire is lit, once you find a purpose, once you find a direction to go, game on. One of the best stories, now I want to get to your question, but one of the best stories, I had a kid come in the other day, and listen, most advice, I don't tell people how to advise, I'm an encourager. I try to encourage. I had a kid come up to me and said, I want to go to physical therapy school. I pulled up his stuff, he had a 2.2 GPA. Instead of saying, you wasted your time, I said, well, can you tell me why your 2.2 is a 2.2? He said, my dad passed away my freshman year. I didn't care about school. My mom passed away my sophomore year. I didn't care about school. He said, I care about school now. And I said, partner, you're going to make a great physical therapist. Because he's going to retake all those classes. We came up with a plan. You could see that fire in his eyes. It was game on. Now what happened? That dude was on a mission. So again, even from that perspective, you know, look, we are bound by our morphology. It's one of the things I mentioned in class. I can't jump 40 inches. I can't run as fast as my daddy used to run. It's one of my favorite stories. You the Campbell boy from Delta? Yes, sir. You run the 100? Yes, sir. Boy, you'll never be as fast as your daddy. So we're bound by our physical morphology, but not a darn person on this earth is bound by their mental morphology. Now again, you may have not found your niche. You may not have found what lights that fire, but it's there. Don't give up. Question? Oh, I'm sorry. Sometimes I get to. Is there anything else? Yes, ma'am. Ms. Carroll. Yes, ma'am, for the person that I've been knowing for 5 years.
You have excited me and lit a fire.
Do you want to get a degree in kinesiology, Ms. Carroll?
Well, so how can we as Joe Public help UL's kinesiology department? It's like you guys are a secret treasure here, it seems like.
I think and again, I try to answer what I think the question is going to. I think the burden lies with us. You know, in other words, kinesiology is not like one of those five, I want to be a fireman, I know what that is. I want to be a policeman, I know what that is. I'm going to major in engineering, I know what that is. I'm going to major in elementary education. I'm going to major in kinesiology. The phone stopped ringing, the dog stopped barking, and this is what I get on it. Where's Dad? You know, and that's a logical question. And all kinesiology just means is human movement studies. And what's really evolved our program is over in biology. I have nothing against biology, that's great. But everything they apply, let's look at how a cat works. Let's dissect a frog. Let's dissect a cat. Let's look at general biology, chemistry concepts. You know, we bring everything back to this. Let's look at the physiology and the biochemistry of the human body when it's stressed, in exercise and stress. Let's look at the mechanics of human motion when we perform activity and when we exercise. Let's look at all the muscles that work on the human body and the motions that are performed in the human body. So really all we did is we found a niche that when our students go off to PT school, OT school, they're helping other students learn how the human body works. Because although they learned a lot about biology, they learned a lot of this. and what's my rationale for why it's working? We got 1,380, and it keeps getting bigger every semester, every semester, every semester. And the compliment there is we wouldn't have so many students if we didn't have avenues for them to go after. You know, we wouldn't have an influx of majors if there wasn't things for them to do. Yes, ma'am.
Well,
Or I should say my mother, who I love very deeply in that group.
First of all, I'd like to say that I think what Ms. Carol is saying, I think what you're doing and what the college is doing right now, in the articles on kinesiology, the information that I'm seeing on kinesiology, I, for one, did not understand what kinesiology was when he went into that. And the things that he's talking about, I used to call it the God rules. Until you've got to want something, you don't really work towards that goal with it. And he had that God want.
Well, but it had to be intrinsically motivated.
Right.
So in other words, my mom, you gotta get the God wants, you gotta get the mom. Yeah.
I'm talking about that's
But it had to be intrinsic.
That's how you get that drive. It's got to come from somewhere within you. But I think that word is getting out through the activities that the kinesiology department is doing, through the college itself, and the word is spreading out about these people.
Absolutely, and that's our job. You know, I think it's our responsibility to educate people on who we are, what we do, and what our options are.
And
You
you
know,
didn't learn science from me.
look, the C's on my transcript said I didn't learn it from. I'm not ashamed to say.
I was in the honors section and I had to take the sciences, but I promise you, I almost flunked my physics and my chemistry. So it didn't come from me, the science.
If you judge a fish by its ability to climb a tree. So to answer your question, I think it's our responsibility to educate. And it's also our responsibility, you know, if you guys come to UL and you major in kinesiology, you know, I will stress it. Serve people. Volunteer for things and serve your community. And it's not just about, you know, planting a tree. It's about all of those doors that you could be opening up without even realizing. It's that conversation with the guy on the plane where he says, what are you going to do? I'm looking for breakfast. And how would I have even had that conversation if I wouldn't have opened the door? So when you serve your community, you know, indirectly what you're doing is you're doing a bunch of interviews. You're not even realizing it. You're opening up that tunnel. So what do you want to do? I'm a kinesiology major. Oh, that's cool. Do you have a, well, I own a clinic. Well, my brother owns a clinic. Well, my good friend owns a clinic. If you want a job, give them a heads up. You know, you impress those people. And listen, being from Delta, I've been there. I love my hometown. I go back and announce the games. Remember, that's what I'm known for, right? I'm not known for any of, which I love this. I thought this was so fun. Of course, my opinion is skewed. I'm not known for any of that stuff in my hometown. You know what I'm known for with the kids? I'm the public address announcer. And that's honorable. Anytime someone asks you to do something, there's honor in that. Dr. Bob Macklin, and I learned that through Dr. Bob, who was orthopedic, he was always on call. He was never not on call. Because if someone asked for him to do their surgery, there's no more honor in this world. So it's honorable to be asked to do things. Okay? But at the same time, in Delta, Louisiana, we are bound by our network capabilities. We already know everybody, right? We already know everybody. So when you're thinking about going to school, and I'm not saying you have to go outside, but extend your network. Take those opportunities to think outside the box and to not be, you know, kind of intimidated to go volunteer, meeting people and making connections. Because that's what it's all about. You know, I have students all the time, and it's hard to find a job. Where are you looking? Just in Scott. You know? Where are you looking for a job? I've been looking in rain for 2 weeks now. I can't find one.
There's nothing in rain.
Exactly. So you live it. You know, man, I haven't found a date for prom yet. Well, who have you asked? Well, I'm only interested in this. May not be anybody in school like that. So you have to be willing
runs out and meet people. You know, how important that is. It's such a difference.
It's hard. It's hard. You know, because kids, and I say kids, young adults, kid relative to me, I'm still a kid at heart, I can tell you. It's all based on the fact that our children, and it's not even necessarily their fault, but it's hard for them to engage in conversation because it's so easy to click send. It's so easy to click send.
The culture is really
Absolutely, absolutely. However, that being said, you know, oh gosh, Brian Campbell, what's her name? Aileen, right? What's the frustrating thing is that we have evolution, and we still long for that connection. We still long to look someone in the eye and shake their hand and say, "Good to see you." So even though it's convenient to click send, human nature drives us to want to do what we do and give someone a hug and shake their hand and talk to them and be face to face. So the convenient part is there, but in reality, the people, and actually that's created a niche. So in other words, all of the wave of students that will now do this has opened up an opportunity for those students that choose to do this. Thank you for having me. It was nice to see you. I'm so appreciative.
It makes an impression.
So again, it's all in how you think of it. For the average person, that may, but again, for some, they say, "Wow, man, that trend is actually my benefit." Taking advantage of that benefit.
Which you might want to introduce the dean because he designed this building.
That's a good point. Everybody, Dean Carlson, thank you for coming.
You're one of the best hires I ever made.
You know, and I think it's that way too. It's up to us, just like it's us to educate people in kinesiology, it's up to me to educate our kids on those topics. And say, listen, if you choose to just kind of stay back, and I can't make you, but at least I can try to offer up advantages of being willing to put yourself out. You know, we've had students, and getting good feedback, you know, students go and volunteer for events from, you know, we don't just anytime we hear something, we promote. And man, I met someone that got me a part-time job. You would not have opened that door unless you put yourself out. You got to just put yourself out.
There's a question here, one.
Dr. Campbell, thank you for the great talk. I kind of really enthusiastic. You mentioned something that I just came in about the physical therapy in school.
Yes, sir.
Professionals.
Yes, sir.
Is there really need to get a 4-year degree to go to the physical therapy school?
Yes, sir. And it evolved back when I was in high school. They used to have a 2-year pre-PT.
Yes.
And then you could apply to, and then the physical therapy school is the one that said, no, we need to evolve this profession into a postgraduate master's, then that changed into an undergraduate doctorate in physical therapy. And it's actually another one of our niches that we evolved here. So they require, it's them, they're the ones that have the hoops. And they say, to get into our school, you need to jump through this hoop, that hoop, and then they design the hoop and what's written on the hoop. And one of those hoops is you got to have a 4-year degree. Now, they don't tell you what it has to be in. You can major in music. You can major in whatever. You have to have the prerequisite classes, and you have to have the hoops. The advantage to us is that everything in kines comes back to the human body. So we have a class specifically designed to teach kids how to properly teach exercise. Rehab exercises, lifting exercises. It's not a weightlifting class, I just go lift it. It's literally teaching the students how to teach someone to do these exercises. We have a periodization class where we teach someone how to design rehab and exercise programs. My classes that I teach, biomechanics, physics of motion. We look at injury biomechanics and how the body works and how the muscles move and illusions of motion. You know, how my students can see how when I do this, even though it doesn't look like my neck moved, it did. Because if it didn't move, I would have done this. These illusions that I teach them, how to see motion when it doesn't look like it happened, and how to not see motion when it doesn't. So that's what our niche is. So the 2-year, you know, you can't get into PT school with associates. Why? Because they set those hoops. They set the standard to get in. And what's evolved also is that most of these PT programs, pretty much all of them now, are doctorate in physical therapy. So literally, you leap from an undergraduate straight into a doctoral program. In the past, we used to have that master's degree, right, where you kind of that transition, where you dabble in a little research, you dabble in a, well, there's no dabbling. You literally go right to it. So another niche that we've had in kinesiology, tons of underclassmen doing research. Tons of underclassmen getting involved and being a part of that research process, because in the past, you used to get that in your master's. There's none of that now, because you're going straight from an undergrad into a doctoral program. And that's happening everywhere. They're talking about in the future having doctorate of athletic training, doctorate of occupation. They're all kind of moving towards, it's an arms race, to try to have these doctorate in audiology. So the master's degree, the traditional master's degree, is kind of dying. They're going right into these doctorates. So that's another thing we do to our students. We try to supplement what you normally would have gotten in a master's in your undergrad. We do a lot
Market
of
was the first to get there with those doctoral programs too.
Absolutely, absolutely. So it's them, it's not us, it's them. And that's actually made our program grow, because in the mid-90s, when it was a 2-year pre-PT program, no one had to really major in kines or body. But then once the PT school said, nope, everybody needs a 4-year degree. Well, now it became, you can get it through this, and you can get it through here, and you can get it through. And I really firmly believe that the reason our numbers are growing is not because of advertising. We're not on TV doing commercials. Have you thought of kinesiology? Well, you need to come on down. I think it's trickle down. We've had students that have had success, that are in school, that are excelling in school, that based on their peers, they know what's going on. They have a very good, they got thrown into the water, and they're just training. And they're not like, throw me off. And that's trickled down to, wow, man, Kines really prepared me for graduate school. Kines really prepared me for PT school, for OT school. So I think that's really where our numbers are starting to grow. You know what it's like? It's like a restaurant that's really, really good. I don't see advertisement for Richard's and African. You know why? Because it's good food. I know where it's at, because I've heard about it. Some of these really good businesses or some of these really good restaurants really don't need to advertise too much, because their product does the advertising for them. So that's how I feel really about our product. And I'm not saying our product is the best, but it's pretty darn good, because we have a lot of students that are getting into these schools and excelling in these schools. They're staying in school. They're not getting booted out because they don't know,
I really like you, and I like what you said, and I really like that your last sentence was really not good, because I really like to advertise you. I want to put you in front of the university YouTube and say, look who we have, and then a lot of people can look at it. And then you can say, look at the professors we have at this university. They can capture attention.
And that's really honorable. I really appreciate it. I really appreciate it. And again, for me, people don't believe me when I say it. I'm really not a salesman. But I believe in this. I'm saying, I'm not a salesman in that, hey, can you go sell? In fact, Miss Carol's like, Brian, can't you sell more car? It's just not me. But this I believe in. I'm all in. I believe in this. I believe in this university. I mean, I think we added it up. My family has 10 degrees from this university.